What is a transverse wave? It is a wave where the movement of particles of the medium is perpendicular to the direction of propagation of the wave. What do we even mean by that? If your wave is going from west to east, then you would expect the movement of particles to be perpendicular. So as a result, your wave, your transverse wave, will always look like this. While on a longitudinal wave, where the particles are parallel to the propagation of the wave, you will have something like this. The movement here is still west to east. This is the difference between transverse wave and longitudinal wave. In transverse, the movement of the particles is perpendicular to the propagation of the wave, while in longitudinal, the movement of the particles is parallel to the propagation of the wave. Let's look at 6.2. Label the points A, B, and C. Let's go ahead and look at point A. Point A in a transverse wave is what we call a trough. So point A is a trough. For the sake of clarity, this point here that I'm highlighting, this is another trough. And B, on the other hand, B, it is the distance between 2 points that are in phase and consecutive. So the distance between 2 points that are in phase and consecutive is what we call wavelength. So B is one wavelength, while C, on the other hand, is the opposite of a trough, is the opposite of A and B. C is what we call a crest. So at C, we have a crest. So what will be the name of this point right here? That would be another crest, yes, like point C. 6.3. How many time has elapsed while the wave moved from R to T? Let's just get rid of this and look at R to T. So we have R to T. From R to T. From R to T, we have 2 points that are consecutive and are in phase. So we have one wavelength. From R to T, we have one wavelength. So the time taken to complete one wavelength, it's what we call the period. So basically, in 6.3, we are required to calculate the period. How do we calculate the period? If you look at the equation statement, you're going to realize that we are given a frequency of 30 Hertz. And we know fully well that the period is equals to 1 divided by frequency. So this is just going to be equals to 1 divided by 30, which is equals to 0.03 seconds. So that is the time lapsed while the wave moved from R to T, the period of the wave. Let's look at 6.4. Are points R and S on the wave in phase? Explain your answer. Let's look at R and S. R is right here, and S is right here. A lot of people will say that R and S are in phase, but that is actually not the case. They are not in phase. So the answer is no here. Let me tell you why the answer is no. You need to know the condition that needs to be met for 2 points to be in phase. They need to be N multiplied by wavelength between the 2 points. What does that even mean? Let me explain to you. There needs to be a whole number of wavelengths between the 2 points. So if there is one wavelength between the 2 points, then they are in phase. If there's 2 wavelengths, they are in phase. If there's 3, if there's 4, if there's 5, then those 2 points are in phase. We need a whole number of wavelengths between 2 points for them to be in phase. So let's look at R and S. From R to S, we have half a wavelength. So we don't have a whole number of wavelengths between those 2 points. So that's why we're saying that the answer to 6.4 is no. And then your reason should be that R and S are not separated by a whole number of wavelengths. They're not separated by 1, 2, 3, 4, or whatsoever up to 100 wavelengths. They are separated by a half, which is not a whole number. So those 2 points are not in phase. I have a question for you. If 2 points are not in phase, does that imply that they are out of phase? or there's another condition that needs to be met for 2 points to be out of phase? Let me know in the comment section. Can you please just leave a comment and tell me what you think about that question? Let's look at 6.5. What does the question say? Calculate the speed of the wave. So what do we need to calculate the speed of the wave? Let's look at the information we have. We know that the frequency is equals to, what is the frequency? The frequency is 30 hertz. We know that the period is equals to 0.03 seconds. What else do we know? Let's look at our graph. We can see that the distance between this point right here to this point is 4 meters, right? It's written here. It's 4 meters. I just covered it as I was trying to show you the points. Yeah, the distance between those 2 points is 4 meters. That is the wavelength. Those 2 points have one wavelength in between them. So we can say that the wavelength is equals to 4 meters. The speed of the wave, V, is equals to frequency multiplied by wavelength. So now we can say that the speed of the wave will be equals to 30 multiplied by the wavelength, which is 4 meters. This is equals to 120 meters per second.